The integral of x minus 1 dx over x squared plus 5x plus 6 can be rewritten as a factored out version, which is x minus 1 dx over x plus 2 times x plus 3. We will then rewrite the fraction using the partial decomposition form. Which is x minus 1 over x plus 2 times x plus 3 equals a over x plus 2 plus b over x plus 3. Then we will multiply through by the common denominator of x plus 2 plus x plus 3 to get rid of all the denominators of the equation. Using that, what is left will be x minus 1 equals a times x plus 3 plus b times x plus 2. Finding a and b, we use the zeros of the factors. The zeros of the factors will be used as values of x. The zeros of the factors x plus 2 and x plus 3 are negative 2 and negative 3, respectively. We substitute them when x is equal to negative 2, then negative 2 minus 1 equals to a times negative 2 plus 3. Negative 3 is equals to a, therefore a is equals to negative 3. When x is equal to negative 3, then negative 3 minus 1 is equal to b times negative 3 plus 2. It will then become negative 4 equals negative b. Therefore, b is equals to 4. Thus, the integral of x minus 1 dx over x squared plus 5x plus c is equal to negative 3 integral dx over x plus 2 plus 4 integral of dx over x plus 3. The answer will be negative 3 ln x plus 2 plus 4 ln x plus 3 plus c. The integral of 5x minus 12 dx over x cubed minus 6x squared plus 8x can be rewritten as a factored version, which is integral of 5x minus 12 dx over x times x minus 2 times x minus 4. We rewrite it using partial fraction decomposition. It will then become 5x minus 12 over x times x minus 2 times x minus 4 equals a over x plus b over x minus 2 plus c over x minus 4. We multiply through by the common denominator of the factors and then get rid of all the denominators. Doing that, what is left will be 5x minus 12 equals a times x minus 2 times x minus 4 plus bx times x minus 4 plus cx times x minus 2. We then use the 0 of the factors as values for x. When x is equal to 0, then negative 12 is equal to a times negative 2 times negative 4 equals 8a. Therefore, a is equal to negative 12 over 8, which can also be simplified or reduced into negative 3 over 2. When x is equal to 2, then 5 times 2 minus 12 equals b times 2 times 2 minus 4. Then it will become 10 minus 12 equals b times 2 times negative 2 equals negative 4b. Then it will become negative 2 equals negative 4b. Therefore, b is equals 1/2 or 1 over 2. When x equals to negative 4, then 5 times 4 minus 12 equals c times 4 times 4 minus 2. It will become 20 minus 12 equals 8c. 8 is equals to 8c. Therefore, c is equals to 1. Thus, the integral of 5x minus 12 dx over x cubed minus 6x squared plus 8x equals negative 3 over 2 integral of dx over x plus 1/2 integral of dx over x minus 2 plus integral of dx over x minus 4. The answer would be negative 3 over 2 ln x plus 1 half ln x minus 2 plus ln x minus 4 plus c. The integral of 5 sine theta cosine theta d theta over sine squared theta plus 3 sine theta minus 4. It can be rewritten as integral of 5 sine theta cos theta d theta over sine theta plus 4 times sine theta minus 1. We use the partial decomposition form to rewrite the equation. It will then become 5 sine theta over sine theta plus 4 times sine theta minus 1 equals a over sine theta plus 4 plus b over sine theta minus 1. We multiply through using the common denominators of the factors. Using that, we are left with 5 sine theta cos a times sine theta minus 1 plus b sine theta plus 4. We use the zeros of the factors as values for x. When sine theta is equals to 1, then 5 is equals to b times 1 plus 4 equals to 5b, therefore b is equals to 1. If sine theta is 0, then 0 is equals to a times negative 1 plus 1 times 4. Therefore, a is equals to 4. Thus, the integral of 5 sine theta cos theta d theta over sine theta plus 4 times sine theta minus 1 is equals to 4 integral of cosine theta d theta over sine theta plus 4 plus the integral of cosine theta d theta over sine theta minus 1. The answer will then be 4 ln sine theta plus 4 plus ln sine theta minus 1 plus c. The integral of x plus 1 dx over x squared times x minus 1. We use the partial decomposition form or the partial fraction decomposition form to rewrite the equation x plus 1 over x squared times x minus 1 is equal to a over x plus b over x squared plus c over x minus 1. Using the common denominator, we remove the denominators of the equations. It will then become x plus 1 equals ax times x minus 1 plus b times x minus 1 plus c x squared. Then we use the zeros of the factors as substitutions for x. If x is equal to 1, then 1 plus 1 is equals to a times 1 times 1 minus 1 plus b times 1 minus 1 plus c times 1 squared. Therefore, c is equals to 2. If x is equal to 0, then 1 equals b times negative 1 therefore b is equals to negative 1. If x is equals to negative 1, then 0 is equals to a times negative 1 times negative 2 plus b times negative 2 plus negative 1 squared c. Then 0 is equals to a times 2 plus 2 plus 2. Therefore, a is equals to negative 4 over 2, which can be simplified further to negative 2. Thus, the integral of x plus 1 dx over x squared times x minus 1 is equals to negative 2 integral of dx over x minus 1 integral of x raised to negative 2 dx plus 2 integral of dx over x minus 1. We can simplify this into negative 2 ln x minus 1 x over 2 raised to negative 1 plus 2 ln x minus 1 plus c. The answer would then be x raised to negative 1 minus 2 ln x plus 2 ln x minus 1 plus c. The integral of dy over y cubed minus 2y squared can be rewritten as a factor dot version, which is the integral of dy over y squared times y minus 2. Using the partial decomposition form or the partial decomposition of fractions, we will get 1 over y squared times y minus 2 equals a over y plus b over y squared plus c over y minus 2. Therefore, 1 is equals to a y times y minus 2 plus b times y minus 2 plus c times y squared. We get this by multiplying through by the common denominators of the factors to get rid of all the denominators. Then we use the zeros of the factors as values of x. We substitute them to the equation. If y is equals to 2, then 1 is equals to c times 2 raised to 2. Therefore, c is equals to 1 over 4. If y is equals to 0, then 1 is equals to b times negative 2. Therefore, b is equals to negative 1 half. If y is equals to 1, then 1 is equals to a times negative 1 minus 1 half times negative 1 plus 1/4. Therefore, a is equals to 1 half plus 1/4 minus 1 equals negative 1/4. Thus, the integral of dy over y cubed minus 2y squared is equals to negative 1 half integral of dy over y minus 1 half integral of y raised to negative 2 dy plus 1 over 4 integral of dy over y minus 2. Then, it would become negative 1 over 4 ln y minus 1 half y over negative 1 raised to negative 1 plus 1/4 ln y minus 2 plus c. It can be further simplified into 1 half y raised to negative 1 minus 1/4 ln y plus 1/4 ln y minus 2 plus c. The integral of x dx over x squared plus 6x plus 13. Using the partial decomposition form or the partial fraction decomposition form, we get x over x squared plus 6x plus 13 equals a times 2x plus 6 over x squared plus 6x plus 13 plus b over x squared plus 6x plus 13. X is equal to a times 2x plus 6 plus b. Can further be solved into x equals 2ax plus 6a plus b. We equate coefficients. Two a equals to 1, therefore a is equals to 1/2. 6a plus b is equals to 0, therefore b is equals to negative 6a, which is equal to negative 3. Therefore, the integral of x dx over x squared plus 6x plus 13 is equals to 1/2 integral of 2x plus 6 dx over x squared plus 6x plus 13 minus 3 integral of dx over x squared plus 6x plus 13 . Therefore, the answer would be 1/2 ln x squared plus 6x plus 13 minus 3 integral of dx over x plus 3 squared plus 2 squared . which can be further simplified into 1/2 ln x squared plus 6x plus 13 minus 3/2 arctan x plus 3 over 2 plus c using the properties of integrals. Find the area under one arch of the curve y equals cosine 1/4x.